All right. So sorry about that, folks. Had a glitch in, excuse me, in videoing the last one. So I'm going to try to edit these two together to make one video, but if I can't, the second half of this is going to be the second video here. So I'm going to pick up here going over the information on the second page of the notes. So the mole is a unit of measurement, okay, MOLE, and then it's abbreviated MOL. So like grams is G, mole is abbreviated MOL. I know, not much of an abbreviation, but the mole is the number of atoms of that element equal to the number of atoms in exactly 12 grams of carbon-12. So they experimentally, they calculated this amount, the number of atoms, to be 6.0, excuse me, 6.02 times 10 to the 23rd. That's how many atoms are in 12 grams of carbon-12. This is referred to as Avogadro's number. Now, I don't make you guys memorize it per se, but if I were you, I'd memorize it. You'll get used, we use it a lot anyway, and you'll get used to it. So it just makes your life easier if you do. You don't have to constantly look it up. You'll probably get used to using it so much that you'll probably memorize it even if you don't try to. But all right. A way to simplify the concept of a mole is that 1 mole of a substance is equal to 6.02 times 10 to the 23rd particles of that substance, no matter what the substance is or the composition. So as opposed to it being like, as opposed to a mole being like a certain amount of a measurement or a certain like size or whatever, it's a specific number of something. Okay, so it's a similar to the way in which a gross equals 144 or something. So there's an actual unit label called gross, and a gross means 144. You could have a gross of pens. You'd have 144 pens. You could have a gross of calculators. You'd have 144 calculators. No matter what the object is, a gross means 144. Okay, or a baker's dozen, if you've heard that, that means 13. So you could have a baker's dozen of donuts, that'd be 13 donuts. You could technically have a baker's dozen of computers, that'd be 13 computers, because the baker's dozen always means that. Okay. All right. So examples here: 1 mole of copper has in it, or is equal to 6.02 times 10 to the 23rd atoms of copper. That's how many atoms of copper in 1 mole. 1 mole of carbon dioxide, which is a compound, has still 6.02 times 10 to the 23rd, but instead of atoms, they're molecules, because this is a molecule, has 6.02 times 10 to the 23rd molecules of carbon dioxide. Okay. All right. So how is this used? Well, this is used to calculate what's called the molar mass. The molar mass is the mass in grams of 1 mole of a substance. The unit label for this is written as a ratio of grams to moles, because it's the number of grams in 1 mole. Okay. The molar mass of a substance is numerically equal to the atomic/formula mass for the substance. So it is calculated in the same manner. So for example, I use water just like I did on the front. You do the exact same thing. You take the number of atoms, you split the elements up, you take the number of atoms of each element, multiply it by the atomic mass for that element, get the total, add them up. The only difference between this, the molar mass, the only difference between the molar mass and the formula mass is your label. That's the only thing that's different. The label for molar mass is grams per mole. So what they're saying for this is for water, there's 18 grams of water in, or equal to, is equal to 1 mole of water. In 1 mole, there are 18 grams of water. That's what this is saying. Okay. All right. So that's it for the notes section. Now, I'm going to, along with this information, because a lot of this is easier to see and understand if you actually do the problems, I am going to walk through one of each type on the homework. So the homework is 10-1 practice problems. Okay, it's a double-sided worksheet, two-page worksheet. You need to either do this on another sheet of paper or print this out and do it on it and then upload pictures, either way, okay, because it's a PDF file. So you'll need a periodic table, either print it out or you can pull it up on your computer or whatever. You need the periodic table, okay? And so here, I'm going to do one of each type. So what is the atomic mass of zinc? When they're asking for the atomic mass of just the element, all you need to do is go to the periodic table, look up the element, so zinc is right here, and write it down. Okay, now, if you round these to 1 decimal place, that's okay. I think in the book they have them all written out, but you need to go to at least 1 decimal place. So if you were doing zinc, you look here, I don't know if you can see that, zinc is 65.38. So you do 65, you could write the whole thing, 65.38, or you could do 65.4 because the 8 rounds the 3 up. And your label for atomic mass is AMUs. Oh, I'm sorry, that's still zoomed in. That's all you need to do. You don't need to show any work for that for the atomic mass ones. Okay. All right, formula mass number 2. What's the formula mass of methylene chloride? CH2Cl2. So to do the formula mass, you split it into the elements. So we've got carbon, hydrogen, and chlorine. Okay. We do the number of atoms. So how many carbon do we have? We have 1. How many hydrogen? 2. How many chlorine? 2. And you do times the mass. So carbon, remember you're taking these to 1 decimal. So carbon is 12.01, so the 1 does not round up, so it's 12.0. Hydrogen, we already know from the previous that it's 1 or 1.0, either way. Chlorine. Chlorine, 35.453. So we're going to go to at least 1 decimal place. So the 4, you look here, the 5 does round that up, so it's going to be 35.5. All right, so we take that, and now we multiply these across. So we've got 12, we've got 2 times 1 is 2, and we've got 2 times 35.5, which is going to be, what, 71? Okay, then we add them all. Add them all down. So we end up with 85, and our label, AMUs. That's the answer. Okay. So on these, I do want to see the work. I will give you points for the work on these. Okay, I do want to see it. I know it's simple multiplication, but I want to know that you know how to like calculate and figure it out. So I want to see the work on these. All right. So atomic mass, formula mass. Those are the ones that are on the front. All of the problems on the front, the label are going to be AMUs. Okay. Now let's go to the second page. Second page, it wants molar mass for each of these. Okay. Molar mass, we do it the same way that we do the formula mass. Okay, we calculate it the same way. So for example, here, methylamine CH3NH2. So we've got carbon, we've got hydrogen, we've got nitrogen, and hydrogen again. Now, we've got hydrogen twice. You don't have to write it down twice. You can just add, you can put it all in one thing here. Okay, so how many carbons do we have? We have 1. How many hydrogens? We got 3 here and 2 here, so a total of 5. We're adding these because the number's not outside of parentheses. We're not like multiplying it in, okay? So 3 and 2 is 5. Nitrogen, we've got 1. Okay, times the masses. Carbon, we know from the last one is 12. 12.0, 12, either way. Hydrogen, 1. And nitrogen, if we look nitrogen up, nitrogen is 14.0067, so 0, and then the 0 doesn't round it, so it's 14. Okay, we do the multiplying. And we add them all. So we get, what is that, 31. Now, the only difference is, because these are molar mass on this side, the label is the only thing that's different. The label is grams per mole, grams/moles. That's the answer. And that's what you're doing for this side. And yes, again, I do want to see the work. All right? That's all there is to it. If you got questions as normal, let me know. Otherwise, good luck.